Hello everyone, welcome back to my channel. Today we'll be solving Leetcode problem 763 partition labels. You are given a string S. We want to partition the string into as many parts as possible so that each letter occurs in at most one part. Okay, a character can occur in a single part, it cannot occur in multiple parts. Okay, for example, string ABABCC can be partitioned into this and this. Okay, if you see, the second string does not contain the characters A and B. Okay, A and B, both the characters occurs only in this particular part. In a similar way, the C occurs only in this particular string, it does not occur in this. Okay, whereas but the partitions such as BA and BCC, if you see, B is the string which is occurring in both the strings, first partition as well as second partition, so this is not a valid partition. Okay, as similarly this thing. Okay, note that the partition is done so that the concatenating of all parts in the order, the resultant string should be A. Okay, so these, let's say these are the partitions which we have made. If we concatenate back the concatenate all the strings, we should again get the original string. Okay, return the list of integers representing the size of the parts. Okay, so the first let's say this is the partition which we have made, so we have to return a resultant list which contains the size of the partitions. Okay, so these are the size of the partition, so this given string can be partitioned into these three strings. Okay, if you notice, characters A, B, C are occurring in the first string, but it is not occurring in the next two strings. Okay, so that is what they are trying to say. Okay, the similar way, the characters which are present in the second string should not present in the rest all other partitions. Okay, so what we can do is basically we should know the last occurrences of the each character. Okay, so if you see, the last occurrence of A, okay, is basically over here. Okay, so that means for sure we have to break till this particular partition, right? So if we break before the last occurrence of A, that means the next string will contain this particular character. That means it is violating the basic rule, right? So we have to include the characters till their respective last occurrences. Okay, if you see A's last occurrence is this, we cannot go beyond that. Okay, if we found another character whose last occurrence is greater than the last occurrences of the previous characters, that means we should go till all the way up till the last occurrence of the next character. Okay, so let me take this example. If you see D's last occurrence is basically here. Okay, so my first thought would be we should have to take the substring till here. So my initial partition would be this. Okay, so I have to start from this character and go all the way till this character, and also check whether all the last occurrences of these characters are also falling before this character, this occurrence. Okay, if not, whatever is the last occurrence, then I have to go all the way till that. Okay, if you see E's last occurrence is D, so that means I have to go all the way till D. If in any case if you see F last occurrence is the same character, so I don't have to extend my current the last partition. Okay, so again E's last occurrence is same, G's last occurrence is same. Okay, D was already done. Okay, so the idea is, once we found the last occurrence of a particular character, we have to extend this last occurrence, this pointer. Okay, we have to extend this partition. Okay, only if we found another character whose last occurrence is greater than this. If not, we have to stick to the same boundary, because all other characters last occurrences are before this character. Okay, this is the example. Okay, where here in this particular string, B and C are the other characters other than A. So if you see, the last occurrence of C, which is before the last occurrence of A, and the similar way the last occurrence of B is also before the last occurrence of A. So I don't have to extend my partition here. Okay, so if I found a character whose last occurrence is beyond the current last occurrence, then I have to update my last occurrence partition. Okay, so that is what the thing. Okay, let's try to code it out. Okay, I hope you understood what I'm trying to say. Let me code it down. Okay, so the firstly I have to identify what is the last occurrences of all the characters. I should know what is the last occurrences, right? So either you can use hash map or you can use an array. Okay, since all the characters in the given string contains the small characters. Okay, so we know that the characters are from A to Z, which are of size 26. Okay, I can define an array called last occurrence, which is of size 26. Okay, so the last occurrence of A will be populated at the 0th index, and B will be populated at the first index, and the last occurrence of Z will be populated at the 25th index, right? Yeah, so the next step is to iterate through the string, okay, and populate the last occurrences. Okay, the last occurrence of the character. Okay, so the character at I minus A, so this will give me an integer. Okay, it will subtract the ASCII values and it will give me the integer. Okay, so A will be populated. If the current character is A, then it will populate at the 0th index. Okay, so now that I have populated the last occurrences, now once the last occurrences were populated, I have to traverse through the array and have to identify the sizes. Okay, so let me traverse through the string. Okay, so let's have two variables called left and right. Okay, which will tell me, so if I'm starting at this particular point, okay, so I have this, the last occurrence of A is here, so my current partition would be this. Okay, so let's so initially the left will be pointing over here and right would be pointing at the last occurrence of the particular character. Okay, left is I and right would be the last occurrence of the current character. Okay, the character at I minus A. Okay, now that I have found the last occurrence, okay, I have to also check whether till the last occurrence are whether all the characters last occurrences fall before that current last occurrence or not. Okay, so I will basically go from left to right. Okay, and also I will also check the current last occurrences. Okay, every time I have to update the last occurrence in such a way that the current character's last occurrence is within the last occurrence of the existing character. Then I should not do any changes. If the current character last occurrence is beyond it, then I should update my right pointer. So at any point of time I will be updating right with the max of current right and the last occurrence of the current character. Okay, s dot character at left minus A. Okay, now that I have updated my right, okay, so I have already processed this particular character which is at the left. Now I have to update my left pointer, right? So once I have reached all the way till the end, that means that means I've already found my partition. Okay, so once I've found my partition, I should add the length of the particular partition to my resultant array, right? So let's define list of integer sizes is equal to new array list. Okay, so I have to update my sizes. I have to add the current partition length to my sizes, and then I should update my I till the current right. Okay, so in the next iteration I would basically go to the next character, right? Yes, so once this is done, all I have to do is the return the sizes. Okay, let's try to submit our solution. Yeah, basic test cases were passed here. Okay, let's try to submit it. Yeah, all the test cases are also passed, right? So here the time complexity would be order of n, because we are in the first place we are iterating through the string and populating the last occurrences. Okay, and in the next iteration also we are at most seeing a character twice. Okay, so first I will go to the last occurrence. No, we are just going all the way from left to right, and then we'll see each character once. Okay, so anyhow the time complexity would be order of n itself. The space complexity is the space taken by this particular array. Okay, so here this array is fixed of size 26, so we can say that it's a constant space as well, right? Let's try to submit. Yeah, I think we have already submitted it. Yeah, that's all about the solution. Yeah, do subscribe to my channel for more such coding videos. Thank you.